Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Now students, let us move to the next question, that is question number 8. Of 2017 JEE Advanced Physics paper, multiple choice questions, more than one options correct. So let us move to question number 8. Students, let us solve this question. Question number 8. A drop of liquid of radius r equals to 10 raised to minus 2 meter. There is a liquid drop of radius 10 raised to minus 2 meter. Having surface tension S is this much Newton per meter. Surface tension is given 0.1 divided by 4 pi Newton per meter. Surface tension is force per length. Divides itself into, so this breaks up into n identical drops. This breaks into k identical drops. So obviously that drops are identical, but then radius will be smaller. Suppose r is the radius of the smaller one. In this process, the total change in the surface energy, because in a given situation, this has its own surface energy, and in this situation also they will have its own surface energy, and the change in surface energy, that is the work done during the process. So change in surface energy equals to delta U, which is the work done during the process, and that work done during the process is given by the surface tension and change in area. This is the formula that we are going to use. That change in surface energy is given to us. This is also given, change in surface energy, that is the work done during the process, is 10 raised to power minus 3 joule. If k is 10 raised to, this k is 10 raised to the power alpha, then what is this alpha? You have to find. The alpha is how much? Now we know that when a drop is broken into so many droplets, identical droplets, then during this process the volume will remain the same, but then surface area will increase. If initially we have a single large drop having area say A1, and finally each droplets and then combination of such droplets, the area goes up to A2. Obviously in the second case the area is more, the change in area is A2 minus A1. That change in area you have to put here, and surface tension is given. We can find delta, we can find the work done. So what we'll do, we will write the formula for W, which is delta U, which is S delta A. S is surface tension, delta A is A2 minus A1, or A final minus A initial. This is the area of area A2 is actually the area of drops or droplets. A1 is the area of single drop. So the single drop is having radius r, and the smaller one drop is having radius r, but then it has k numbers, so k times we'll write. This is because it is a sphere, so surface area is 4 pi r square, 4 pi r square. This is A2, so it's r square. This is the surface area of a single droplet. There are k times, so k times k many droplets are there, minus 4 pi, the single drop having surface area r square. Now Now I take 4 pi common, so 4 pi s comes out, and this is r square k minus r square. So from here I have to introduce the concept that this r is given, this r is given, capital R is given, but this small r is not given. So we have to write this small r in terms of capital R using the concept that volume is constant. Volume is constant during this process of breaking of single droplet into so many droplets. The volume will remain constant. If volume remains constant, then what I will get from volume remaining constant? If volume, initial volume is equal to final volume, initial volume, that is only one droplet, so volume of the sphere is 4 by 3 pi r cube. There is only one sphere having radius r, volume is this. Here we have so many droplets, but each of a radius r, so each is a sphere of volume r cube, but there are 8k many droplets, k times, so it is k times 4 by 3 pi r cube. So volume will be same. From here I can cancel 4 pi by 3, 4 pi by 3. So from here r cube is r, capital R cube by k, or r is r divided by k to the power 1 by 3, or r square is r square divided by k to the power 2 by 3. This is the expression for r square in terms of this capital R square, because we want this r square to be replaced by this capital R square. Or I can do one thing, I can okay, let us substitute that and put this value r square as this over here. If I put that here, then this is 4 pi s. R square is capital R square divided by k to the power 2 third into 1 k is over here minus r square. Okay. So you can see that this k to the power 2 by 3 goes up. One more line I'll write, 4 pi s. This r square and r square also come out. R square you can take it out. This will be k to the power 1 minus 2 by 3, because this goes up, minus 1. 4 pi r square s. This is 3 minus 2, that is 1. 3 minus 2, that is 1. So it's 1 by 3. This is k to the power 1 by 3 minus 1 equals to your delta u. So if I got my delta u, then that delta u comes out to be 4 pi r square s and k to the power 1 third minus 1. Now I will put the values of k to the power everything. This is given as delta u is given as 10 raised to minus 3 over here, so I'll put 10 raised to minus 3. 4 pi r square into s. S is 0.1 divided by 4 pi, so in place of s I'll write 0.1 divided by 4 pi into r square. R is 10 raised to minus 2, so squaring it is 10 raised to minus 4, k raised to 1 third minus 1. Now this 4 pi and this 4 pi will cancel. This is 0.1, that is 1 divided by 10, that 10 raised to minus 5. So this is 10 raised to minus 3 and this is 10 raised to minus 5, and this is k raised to 1 third minus 1. This is 10 raised to minus 3 and this will cancel, and 10 raised to minus 2 will be left, and this side it will become 10 raised to 2. So here it is 10 raised to 2 equals to k raised to 1/3 minus 1. So 10 to the power 2 is this, and k raised to 1/3 equals to 10 raised to 2 plus 1. That is, if I, this is around 101, and k raised to 1/3 is 101. If I square it, if I don't go for 1 also, approximately I can solve like this. Okay, first let me put this and then we'll discuss. This is k raised to 1/3 is this, but our question is given that k is 10 to the power alpha. So it write the expression in terms of 10 raised to something. So if I take the cube of both sides, then this becomes k and this becomes 101 to the power 3. 101 to the power 3 I have to find, and so to find 101 to the power 3, we can also write that from here I can just make a little change for approximation. This 100 plus 1 I can approximately write 100. If I do that, then k raised to 1/3 is 10 raised to 2. So from here, if I take the cubes of both sides, then this becomes 10 raised to 6. K is 10 raised to 6. If k is 10 raised to 6, then k raised to alpha, if I write that it is given that k raised to alpha is 10 raised to 6, k is 10 raised to 6, and that k is saying as 10 raised to alpha, because the question that k is 10 raised to alpha, if I get this k is 10 raised to 6 and I compare this with 10 raised to alpha, then it's alpha coming out to be 6. If you do that, then also get k alpha is 6, or you can solve it to get also. This can be written as 100 plus 1. This can be written as 100 plus 1 and to the power of 3. Then if I take 100 common and neglect this value, or I can take something like 10 raised 101 multiply by 100 and divide by 100, and then put this number. If I take 100 common out from here, then it will be 10 raised to 6. Obviously this you can write like that. It is 10 raised to 2 is there, if taken out 10 raised to 6, and inside it is 1 plus 10 raised to 6. Here 1 10 raised to 6 to the power 3, and this is 0.000 something like that, so this is to be neglected, so you can write approximately this 10 raised to 6. So this is how I get the answer. The answer to this question, that what is the value of alpha comparing this, comes out to be 6. Okay, thank you.